All right, lesson 9, composite functions. So, last time what we were doing is we took 2 or 3 functions, right? And we would add the functions, or we would divide the functions, or multiply, right? And remember what we were doing there is we were really like adding or subtracting, multiplying, dividing the y values. So for any given x value, you guys were looking at those y values, and those were what we were performing the operations with, right? So now these ones are a little bit different. These are called composite functions, and they are going to have we got to get the notation down here too, because they can be written different ways. So quite often it will be written like this, like h of x is equal to f of g of x, right? And or it could be f of and then open dot g of x, and then I'll kind of explain, and you can just keep going with that. But that probably doesn't make much sense to you guys yet. I'll kind of go forward a little bit here. So okay, so what's going to happen here is we're going to be putting functions inside of functions, right? I often kind of like think about this as you guys know those like Russian doll things, you know, where you get like a doll inside of a doll inside of a doll. It's kind of like that, right? But with functions, so we get like a function inside of a function inside of a function, right? We're kind of working that way. So one of the main things, I'm going to go through some examples as we go. One of the most confusing things about these, I guess, is what changes with the domain as we go through this. So if I have, let's say, some function like this, like f of g of x, which can be written that way or this way, this means that we've got the function g is inside the function f. Then if I'm looking at the domain on this one, then the domain, we have to consider the domain of g of x, because that's going to be that like if there's some number that isn't allowed for the or for g of x, then that number is not going to be allowed for the new function f of x. It has to be allowed in the inside one to be allowed in the outside one as well, if that makes sense. And then whatever we do when we combine those functions, let's say we do something where it requires that we divide by x, or so then 0 would be a number that we can't divide by as well. So we also just have to look at the new function and see, did we introduce any new restrictions by doing it. And I know a lot of that probably didn't make sense. I think this is going to be make a lot more sense when we start doing some examples. So okay, the range, just like the other ones, the range is probably going to be the easiest to just actually graph it, because sometimes strange things can happen with the range. So we can graph it, find where the max ends up being, find where the min ends up being, and go from there. Okay, so if we're actually gonna simplify these things or put them in, then here's typically our steps that we're going to use. So we're going to start with f of g of x. And what we mean by that is if it would have been written like f of g of x to begin with, we're going to rewrite that as f of g of x. Now, one thing I want you to know this when we're looking at these two is that f circle g of x, doesn't that look a lot like what we did in the last lesson when we had we had bracket f g of x? It's a little bit too big a circle. Do you guys see how those are different? What's different about those two, the way I wrote those? Those are saying two totally different things. So it's, one's fog, yeah, and actually I say that quite often, is I'll say fog of x, because we write that so often. But this one actually means this. It actually means f of g of x. This one means that g is inside of f. Where if it's written like this, f dot g of x, that means f of x times g of x, right? So careful on that. You got to keep your eye open for like what symbol it is, because they look very similar, but you're going to handle it completely differently. Okay, so if it's fog of x, then we're going to be dealing with composite function. Okay. So step number 1 there, was replace fog of x with really the way it looks more familiar. I'm going to write that as f of g of x, like that. And the reason why I do that is because now I can kind of clearly see that g of x is just inside of f of x. It's just It's kind of an easier way to kind of think about it, I think. Okay? And then we're going to replace g of x with whatever g of x is. And then within the original f of x function, replace all x's with g of x in the equation, and then write the answer in simplest form. So again, I think let's get doing some, and I think it's going to make more sense. So here's a standard example. It's going to say if f of x is equal to some function, 3x squared plus 1, and g of x is equal to some other function, like 4x minus 2, find fog, or f of g of x. So very first thing I'm going to do is I'm going to rewrite this as f of g of x. And you know what I'm going to do here too? You guys don't have to, but I'm going to make this g of x a different color. Just so you can kind of see what we're doing there. Like the g of x is inside the f of x there, right? And maybe I'll make this green so we remember, and this will be black. Okay, so then f of g of x, well then what we're going to do here is we're going to say, okay, well f of x, and then what am I going to put in its place, like inside those brackets now? Yeah, well, so like what will actually replace the g of x in this case now? Right, what g of x is, right? So g of x is 4x minus 2. So we're going to replace that with 4x minus 2, right? We just threw g of x in its place. Okay? Now, what was f of x equal to? Yeah, so f of x was 3x squared plus 1, right? So remember what that means, though. When we have like f of 2 or f of 3 or something, what did we do? Well, we put 2 everywhere that there was an x in the function, right? Or we put 3 everywhere that there was an x. But now we're going to be putting 4x minus 2 everywhere that there was an x. Okay, so we're going to write it as 3, and then instead of an x, I'm going to put brackets down, squared plus 1. And then what am I going to replace that open space with? What am I going to put in there? 4x minus 2, right? I'm putting g of x in there. So 4x minus 2. You guys get that? And that's it. That is the function f of g of x, but we just don't like leaving it that way, right? So here comes your guys' algebra that we've been doing for years now, right? We need to expand this. So expanding this all out, we would end up getting, well, I'm going to kind of cut to the gist here. I'm going to leave the 3 for a second, but if you expanded the 4x minus 2 squared, right, you'd write them beside each other, and then you'd have to FOIL it all out. You'd end up with 16x squared minus 16x plus 4, and then plus 1. Okay, I'm going to carry on down here. The next step we would do here, sorry if you guys don't have much room, is we'd expand the 3 in. So we'd have 48x squared minus 48x plus 12 plus 1. And then just collect our like terms. So in the end here, we'd have 48x squared minus 48x, and then plus 13. Okay, so that's the new function. That's our function f of g of x. Okay, so that's really the skill. So now we're just going to do it different ways here. So these ones could be a little bit more, or a little bit confusing, because this one says GOG or g of x, right? So again, it's kind of hard to like figure out what's happening here when it's written in this form. So I'm gonna, step number 1, I'm gonna write this as g of x You know what? I'm going to make them different colors again, too. So I'm going to say, I'll make this one red. So g of x. Okay, so I'm going to write this as, so g of, and then what was g of x again? G of x was 4x minus 2. So 4x minus 2. Okay, so that's what we're dealing with. Oh, that black bracket. Okay, and then this is where it can get a little bit confusing, right? Because now I'm going to take, like, what is g of x again? It's 4x minus 2, right? So I'm going to go 4, and then instead of an x, I'm going to leave a bracket, minus 2. And then what am I putting in place there? 4x minus 2, right? So we're putting it into itself here. Okay. And then same thing. We'll just do some little bit of algebra there. I think you guys could get to this point, so I'm going to cut to the gist here. We'd have 16x minus 10. All right. For the sake of time, I think we'll be okay on the next one. I'm going to skip through that.
It would just be
It'd be the same thing. So now it would be, so this, we'd write this as g of f of x. And then that would be, well, g of x is 4x minus 2. So that would be 4 bracket minus 2. And we'd be putting in f of x into there. So f of x would be 3x squared plus 1. And then we'd expand it all out. Yeah? Okay. And then f of x. You know what? Let's take a second. Do that one. Okay, perfect. So I know I showed you that, like, these steps, right? And that works, like, if you want to do that. But one way the other way that I do it is that I just write down the parent function, like the main one, and then just write it with, like, open brackets to begin with. And then I know just anything that, like, the next function is just going to be inserted into those brackets. Right? So just write, instead of x's, just leave it as brackets and then just put the new function in place of the brackets there. Okay? All right, next ones. So it says, if f of x is equal to 4x and g of x is equal to x plus 6 and h of x is equal to x squared, determine each value. Okay. Yeah, h of x is h squared, or is x squared, sorry. Okay, so now what's different? The last time we actually had functions that we were putting into functions, right? Now they've actually given us some value for x, right? They've given us a number. So first off, what am I expecting here? Am I expecting, like, a function out of this? What kind of thing should I be getting out of here? I'm getting a number, right? Because they told me some value of x. I'm expecting some value of y to be my output. Okay? So different ways you can do this. I'll do it both ways just so we can kind of get the hang of it. We can do the same thing where let's go, okay, f of g of x. F of g of, and I'll just call it x for a minute. And then I'll do that same little technique where I'm going to go 4. I'm going to leave my brackets, right? So instead of an x, I'm just going to leave brackets there. And then I'm going to be putting in x plus 6. You guys are good with that? So that would be the general function there. All I did here, maybe I'll make them different colors again. Right? So, like, the 4, like, the red part was my 4x, right? That's like what the red part was there. And then the x plus 6 was my g of x. Okay, so I just put one into the other. Now it just wants to know what f of g of 3 is. Okay, well, same as what we have been doing, right? We're just going to put 3 in place of x there. So then that would just be 4 times 3 plus 6. So that's just going to be 4 times 9, so 36. Okay, so we can do it that way. You can, like, put it together as a general function. But actually, there's an easier way to do this. We could have just went, okay, let's see. We can even do this in our heads here. let's just figure out what g of 3 is first. Okay, so let's say, okay, what is g of 3? G of 3 is equal to, well, g of x was x plus 6, so what would g of 3 be? 9, right? That would be 9 plus 6. So g of 3 is equal to, sorry, what did I say? G of 3 would be 3 plus 6, which would be 9. Yeah? Okay, so now that I know g of 3, maybe you guys are kind of seeing where I'm going here. All I got to do is go f of, well, what is g of 3? G of 3 was 9, so let's just go f of 9. Right, because that's what g of 3 is. It's 9. So f of 9 is, okay, well, 4 times 9. So f of 9 is 36. Right, so you can find the numbers first and then put them in, or we can do the general thing and then do it after. It's typically, if they give you numbers though, the second way I did it here is probably the easiest way to go. Just find them like piece by piece. Okay. Okay, so let's do this one. Actually, can you guys do this one? I'll just pause there for a second. Can you guys find f of g of h of 2? Okay. Okay, so this one's not going to be as bad as you think once you kind of get the process down here. So we start from the inside and we work our way out, right? It's kind of what we're going to do, just like normal algebra, right? You start at the inside and you work your way out with brackets. Let's figure out first just what h of 2 is, right? That's going to solve my first problem. So let's just find that one. So h of 2 is, okay, well remember, so h of x is equal to x squared. So h of 2 is equal to 2 squared, which is 4. Okay, so now we have we've solved one part. Now we have a different question pretty much, right? Now what the question is what is f of g of, okay, well h of 2 is 4. That's 4. So now my question just became a little easier. Brand new question. Just think of it like you've done one part. Let's do part number 2. Okay, so now the question is, what is g of 4? So g of 4 would be, okay, well g of x was x plus 6, right? So g of 4 will be 4 plus 6. So g of 4 is 10. Okay, brand new question. We've kind of figured the next part out, right? So now what we're at is f of, okay, well g of 4, I can replace that with 10, right? G of 4 is 10. So we can say, so now the question is just saying, what's f of 10? Okay, so f of 10, we can just see right from our original one there, f of 10, well, f of x was 4x, so this will be the same thing as 4 times 10. So f of 10 is equal to 40. Just piece by piece, right? It's like when they get bigger, they're not harder. We just have more steps, right? This is all. Okay, next one. So now it's going to get a little bit different because we're going to throw like a square root function into it. So it's just going to change the domain is really going to be the biggest issue here. Okay, so this one's saying fog of 2. So very first thing I'm going to do is rewrite this because I don't like the way that that's written. I'm going to write this as f of g of 2. And you know what? I'm going to do my little thing with different colors again. And I'll make that red and that purple. Okay. Okay, so let's rewrite the first function. So I'll do the red one there. So that's going to be the same thing as, okay, let's go. Just leave in brackets, right? Instead of an x, I'm just going to like leave the brackets there because I got to put something in for x's, right? So it's going to just leave the brackets, squared, minus 3. What goes into those brackets? Square root of x minus 1, right? Good. Square root of x minus 1. Okay. Now we could say, Well, we'll put 2 in its place, right? So then we'll actually just put in... Well, actually, you know what? Let's simplify this a little bit. What do we get if we go, if we square the square root of something? It's just going to be like the number underneath, right? They cancel each other. So I can make this easier. This whole thing would just become x minus 1 minus 3. That all becomes... So x minus 1 minus 3 is x minus 4. Yep. Okay, I think my key's wrong. Okay, so then we're just going to put in 2 for that. So we end up getting 2 minus 4. So we get negative 2. Okay, so that first one I did the method where we actually put the whole function in. Let's do the other one with the other method. So this is saying f of g of 0. So f of g of 0. So let's just figure out what g of 0 is first. Okay, so g of 0 would be... Yeah, g of 0. Yeah. G of 0 doesn't exist, right? Oh, actually, no. Yeah. Oh, yeah, sorry. Yeah, g of 0 doesn't exist. So it does not exist. So, does not exist. Okay, so we're kind of getting at some hints here when we actually figure out the range and everything for these ones, that this isn't going to work out, right? So that point just doesn't exist. Okay. Yeah, let's find the other points. It's going to help us for the next question. So the next one here is going to be g of f of 2. Yep.
What if we use the first method in the second question?
You'd end up with the same thing where... Okay, so for this one, let's figure out what f of 2 is. So f of 2 would be... So what's f of 2? Yeah, 1, right? Because f of x was x squared minus 3. So this is really 2 squared minus 3. So this is going to be 1. Okay, so our question becomes a little simpler. This is just really saying what is g of 1? Okay, well, g of 1 would be the square root of 1 minus 1. Does that exist? Sure does.
Can't you not take the square root of 0?
You can. Square root of 0 is still 0. You just can't take the square root of a negative. Yeah, you can't divide by 0 yet. Yeah, so that's going to just be 0.
What's so wrong about dividing by 0?
Okay, next one. So let's go. So for the next one here, we're going to have g of f of 0. So we're going to write that one.
Can you square 0?
Okay, so f of 0. So f of 0 here would be... Okay, let's just go do it this way. F of 0 is equal to 0 squared minus 3. Okay, so f of 0 is equal to negative 3. So the question will become, what is g of negative 3? Might that be the same question? So g of negative 3 would be the square root of negative 3 minus 1. So square root of negative 4 does not exist, right? Can't do it. Oh. All right. State the domains and ranges for just f and g. Okay, so we're going to state the domain of just f and just g without combining them or anything like that. So the domain of f, just x squared minus 3. Okay, so your domain there Here, let's do for f of x. Make that red. Your domain, we'll just say x is a member of the real numbers. Because I'm getting more and more lazy every time. I'm not writing out the whole thing. Okay, your range. So range will be, well, what do you guys think from this one? You could graph it, figure out what it is, but this one's symmetric, right? It's going to be a symmetric parabola. And the whole thing has been shifted down 3, right? Y-intercept's at 3. The bottom of our graph is probably sitting at -3, right? Yeah, so we're just going to say y has to be greater than or equal to -3. Okay, g of x. The domain here would be, what would the domain be for g of x? Remembering that g of x was the square root of...
X is greater than or equal to 1.
Yep. Yeah. X is greater than or equal to 1. Do you guys want me to remind you how, like, why that worked? Square root of x minus 1. Okay. So what number can't you take the square root of? A negative, right? So if I can make myself like a little equation here. I could say, well, okay, well, that means then x minus 1 has to be greater than or equal to, because it could be 0, right? So greater than or equal to 0. Okay, so then, oh, did I get that wrong? Yeah, I did. Oh, no, never mind. Good. Yeah, so x, just bring the 1 over. X greater than or equal to 1, right? Yeah. Okay, and then the range there is going to be y has to be greater than or equal to 0. And we got a whole unit coming on square root functions and why that would be. But if you think about it, our typical square root function is just that, right? We kind of did like a bunch with, or some questions with that. And all that's happened here is this thing has shifted 1 to the right. So it's still starting, like, you know, starting here, the whole graph would just be like that now. So it's still just going to be, for your range, greater than or equal to 0. Okay, now, the good stuff. So find the general equation for f of g of x and g of f of x. Okay, so the general equation for f of g of x would be, so f of g of x is equal to, okay, so f of x is what I'm going to write down first. So f of x was x squared minus 3. But I'm just going to write it with brackets. Squared minus 3. Right? Because this is where I'm going to insert the new function, right? And I'm going to insert g of x. So the square root, oh, that was terrible. The square root of x minus 1. Okay, so we end up getting, we already did this one, right? It ends up being x minus 4 up at the top. Okay, so that is the general function, but there's some domains here. So when I say the general function, we also want to list like what x values are allowed and which ones aren't. Okay, so in this case, it's going to be, we're also going to have to tack on there, we'd say where, like a little comma. And then we're just going to state the domain there, where x is greater than or equal to 1. Now, why did I say greater than or equal to 1? Yeah.
That's the domain that's common to both functions.
Yeah, exactly, right? So the domain of the original was x had to be greater than 1, right? The inside function there. So then that's also going to have to be true for my final function, right? Whatever, like, because I'm going to have to put x values in for g of x, and if they don't exist, then they're not going to exist for f of x. Does that make sense? Yeah. Okay. So that's our general function for that one. Now we'll do g of f of x. So g of f of x is going to be, okay, so I'm going to write down the square root of, and then instead of writing an x, I'm going to write brackets, minus 1, right? Like that is the g of x function. And then I'm going to throw in f of x. So f of x was x squared minus 3.
square root, would that be over?
Right over, yeah, because it was right over for g of x, right? Yeah. Okay, so then just simplifying that, I have brackets here. They didn't really need to be there. I just put those there just so that I knew I was inserting a function. Those brackets are kind of meaningless. I can just take them away, and we just end up with the square root of x squared minus 4. Okay. Now, the new domain of this guy is going to be, just let me write it down first and I'll explain where this comes from. So x is less than or equal to negative 2, and x is greater than or equal to 2. Okay, so what I was looking at here is originally f of x didn't have any restrictions, right? That was just x as a member of the real numbers. So I would have to include that. If there was some restriction on f of x, that would also have to be part of it, but there's not. And now for g of x, I've kind of introduced like a new restriction that's going to happen here, right? I have to figure out all the numbers that aren't allowed so that I don't get the square root of a negative. Now, a good way that you can do this, especially now, is you could graph that and see where it actually exists, right? You can actually just do that yourself. Or we could do the same little trick there where I could say, okay, x squared minus 4 has to be what? It has to be greater than or equal to 0. Okay? So I'm going to, well, the problem with this one, I'm just going to say equal to 0 for now, just so I can figure out like where my numbers are. So let's do a little algebra. We're going to have x squared is equal to 4. And then I'm going to take the square root of both sides. So square root of that side, square root of that side. So we get x is equal to 2. Where did I get negative 2 from? Plus and minus, right? Like when you take the square root of a number, it actually has both. It's going to be plus or minus. Now, whether or not it's going to be greater than or equal to 2, or whether it would have been like in between those, is a little bit tougher, and we do like a lot more of that in calculus. But what you can always do is try it out. So like what I've got going on here is I know like if this is 0 and this is negative 2 and this is 2, then what this is saying up here is x has to be, let's say, less than, has to be less than negative 2 and greater than 2. A good way to do this is actually just try it out. So I could try out, let's say, the point negative 3. Because I know these 2 points are like where it would be 0. So I can try negative 3, right? I could try like this point there. If you threw negative 3 into here, that would be negative 3 squared would be 9. Minus 4, I'm still positive, so I'm good, right? So I'm in the right territory. If I threw, let's say, negative 1 into this, right? Negative 1 would be negative 1 squared is 1. Minus 4 is negative 3. I can't have a negative, right? You can't take the square root of a negative. And then you could try over here. If I threw in 3. 3 squared is 9 minus 4 is 5, so I'm positive. So you can see that it actually does follow that pattern, right? It's a little bit harder. You know how we did like I just did algebra with the greater than or equal to thing? It kind of gets tough if I would have made this like greater than or equal to. It doesn't work out so nice with the directions of which way it's opening when there's 2 values like that. Does all that make sense? We don't have too many of those, but it's worth you guys knowing because, like I said, calculus, it'll come up a lot.
How can it equal the negative 2?
Okay. So graph f of g of x and g of f of x state the new domain and range. You know what? Let's move on for that one. Yeah. Okay. So let's go. H of x is equal to f of g of x. Determine f of x and g of x. So the idea here is you could have multiple answers in this case. So they're saying that h of x, like our new function, was made from 2 other functions. It was made from f of x and it was made from g of x. Okay. Any idea what, let's say, f of x would be equal to when you're looking at this function?
F of x would be x squared plus x plus
Nice. Yeah, you guys. Okay, so I'm gonna write it down. Maybe you'll see it a little bit more clearly. So it'd be x squared plus x plus 1. Can you guys kind of see? So if I just replaced like these x minus 2 for both of those with just x, that would have been like my parent function there. That would have been like the main function. Yeah? Let's do it, and then we'll go backwards so maybe you can see where it came from here too. So any idea what g of x would be then? X minus 2. So like I said, if you're having trouble seeing that, let's go back the other way now. So if I, like, let's say started with these two functions and then I wanted to write it as h of x, then what I would do is I'd start out with f of x, right? So I'd say, okay, f of x is going to be, and I'd open my brackets up, right? Can you guys see that that is f of x? So I've just replaced the x's with the brackets, yep. And then all I would do is I would just throw in g of x into the open spot. So that would be x minus 2, x minus 2. It says there could be multiple answers. This one would be kind of harder to see how there'd be multiple answers, but in the next one you can see that there could be different ways of looking at it, right? So this one, you could say that g of x was, well, what do you guys think? What would, let's do f of x first. What could f of x be? Yep.
Square root of x.
Sure. Yeah, it could have been square root of x. And then if that was the case, what would g of x have been?
X cubed plus 1.
Nice, yeah. It could have been, so g of x could have been x cubed plus 1. Can you guys see that if I like just threw in x cubed plus 1 in place of x there, it would be that same function? Okay. What else could it have been? We could have said f of x was,
Root x plus 1.
what'd you say?
Root x plus 1.
Yeah, exactly. It could have been the square root of x plus 1, right? That could have been our main function. And then if that was the case, then g of x would be what? X cubed. Yeah. And then in that case, right, if I threw x cubed in place of x, then I'm back to that combined function again. Yeah? Okay. Good. All right. Last one. So a spherical balloon or weather balloon is being inflated. The balloon's radius, r, in feet after t minutes is given by r is equal to the square root of t. Recall that the volume of a sphere is volume is equal to 4/3 pi r cubed. Now it says express the volume of the balloon as a function of time. Okay, so right now the volume of the balloon is being expressed as a function of the radius, right? Like that's the function. You could originally write that as v of r is equal to 4/3 pi r cubed, right? So then I can throw whatever r value I want in to get whatever volume out. But this question's saying express this as a function of time. So, any idea what we want to do here? Yeah.
Replace your r with root t.
Right. We're going to replace our r with root t because that's what r is, right? We're going to take this function and we are going to put it into that function. Yeah. Okay. So we're going to rewrite this as the volume. So v of t is equal to 4/3 pi, and then instead of an r, I'm going to do my same little trick. I'm just going to put brackets there. And then cubed, right, because that's the way it would look. And then what's going in those brackets? Square root of t. Okay? And now we just got a little bit of simplifying to do. So volume as a function of time is equal to 4/3 pi. And then how can we rewrite this a little bit different? Do you guys remember how we write the square root of something as an exponent? What would the square root of t be as an exponent? That would be t to the power of...
1/3.
Yeah, 1/3. Yeah, great. Or sorry, well, not 1/3. Yeah.
1/2.
1/2, right? So, yeah. Here, I'll remind you guys. Let's go the square. Let's say we had like the third root of 4 to the power of 7. As an exponent, that would be the same thing as saying 4, and then the exponent goes on the top part, and the index goes on the bottom for your roots. Okay, so yeah, that's how that works. So this one is like the square roots. That's really a 2. This is to the power of 1. So you'd say that was the same thing as 1 over 2, or a half. Okay, so we're just going to rewrite this now as t to the power of a half to the power of 3, which would be the same thing as 4 over 3 pi times t. Here, I'm going to get the brackets out of there now. T to the power of, what do you do when you go an exponent to an exponent? Multiply, right? We multiply that, so 1/2 times 3 is 3 over 2. Okay. And now it says, after how many minutes will the volume be 4,000 feet cubed? So round to the nearest minute. So, right, so now they've given us the volume, so I am going to replace volume with the number they gave us. So 4,000 is equal to 4/3 pi times time to the power of 3 over 2. And now we just have a little bit of algebra to do, right? So we're going to go, if I just go 4,000 times 3 divided by 4, right, just getting rid of that first part here, right, doing a little algebra, we end up getting 3,000 is equal to pi times time, power of 3 over 2. I'm going to divide by pi on both sides. Okay, and then what do we get here? So then we got 3,000 over pi is equal to t to the power of 3 over 2. All right. What do you guys think we got to do now? How do we get rid of the 3 and that 2 in the exponent?
Could you do it like the reverse way we did it before?
Yeah.
And then put it back into the root?
Yeah. So remember the 2 on the bottom there. That really means that we're square rooting that right now, right? So how do I get rid of that one? So right now it's being like square rooted. So we're going to square it, yeah. So we could actually square both sides, and that will get rid of that one. So we've got 3,000 over pi squared is equal to, and then we've still got t to the power of 3. And then cube root that. And then I think my key is wrong here, so can you guys figure out what that is? And then I'll do it with you here. Yeah, so never mind, key is right, just wasn't written the right way. So we've got 96.97, so that'd be 97 minutes.